Hello everyone, today we're going to be starting a new LeetCode Explore playlist. I'm very happy to be continuing on with this series. I've been having a lot of fun with it. I think the first one for the LeetCode Explore card regarding the beginner's guide went very well. I know a lot of people watched it, a lot of people got some great value out of that. So continuing along with our journey here, today we're going to be moving to the Arrays 101 Explore card. I feel like this is the next best logical step for us to move into, so I hope you're ready to get into some cool content. I think what I was thinking about this one, so this Explore card does introduce us to the concept of an array. It says here how we can work with arrays in Java. I am going to leave these posts up to you to read, but if you'd like for me to go a little more in depth in these posts and especially how to use JavaScript arrays, then I'll be more than happy to do that. But what I'll do just for now is I'm just going to mark these as being complete. Again, if you want for me to dive deeper into these and show you some techniques for using arrays in JavaScript, please let me know in the comments below. Else, we're just going to go ahead and start off with the first question in the introduction, which is max consecutive ones. So what I want to do is I normally don't like working in this sort of view, because this view gives us, it doesn't give us the stats that the normal problem view does give us. So let's go max consecutive ones. Let's look it up. I have already solved it, but I just want to do it now in this nice clean slate like we're all used to. Okay, so let's go ahead and read the prompt. Given a binary array nums, return the maximum number of consecutive ones in the array. So really what we're looking for is we know that all the ones are always going to be next to each other, right? So we just need to find anytime that there is a 1, we can increase some counter. And whenever there's a 0, well, it means that that counter needs to be reset to 0, because a 0 indicates that we no longer have that stream of 1s, right? So we can set that counter to 0, and then now when we start on our next stream of 1s again, we'll go ahead and start the counting again. Now the main thing to keep note of is I just said here that when we get to a 0, we reset the counter, right? We notice that at the end here, there's not another 0, so we'll never get a chance to actually reset the counter. So we won't know if we've actually, reached the end of a stream or any other condition, right? So we got to make sure that at the end of this algorithm, we return the most recent max that we've gotten to, because our max calculation will only be done when there's a 0 or we've reached the end of the array. So let's go ahead and set this up. What I'm going to do is I'm going to create two variables. One of them I'll say ones count. I'll set this equal to 0. The ones count is going to be the thing that actually keeps track of the stream of ones. In other words, every time there's a 1, we'll increase ones count. And then we'll also have ones max that for now I'm going to set to a very large negative number. That way, there's nothing, like anything's going to be greater than infinity. So anytime we have something greater than this, we'll go ahead and update that. Then what I'd like to do is I want to use a for const of loop, and we can say, for example, for const n of nums, n in this case representing a number, we'll go ahead and do exactly what we just talked about, right? So if n is equal to a 0, what is it that we want to do? Well, we know that our ones max should be equal to the max value of whatever the previous ones max was, in this case negative infinity, or the value of ones count. And we also need to make sure that ones count is also set to 0, because we need to get ready to start counting the subsequent ones. Else, in the case that it is a 1, we'll just go ahead and say ones count plus or equals 1. And like I said, at the end, we need to make sure that we also return the latest max, right? We can't just return ones max, because remember, the update of our math max is only happening if it's 0. So in this case, we'll only update it once, and it will be 2. Now at the end, when we get 3 ones, if we just return max, we never updated it because we never got to another 0, so we'll return 2. So we need to make sure that we return the max of ones max or the most recent ones count. So let's go ahead for both of our test cases, run the code here. We get a 3 and a 2, which matches with the test case results. So let's go ahead and click on submit here. And we get 90.39% for time complexity, And then for memory usage, 39.35%. So I think very nice statistics for the first question of Arrays 101. If we think about it, we're only iterating over nums once. We're only doing one pass, and we are going through every single digit inside of nums. So that's what's going to give us our linear time complexity. And as far as space complexity, we are only dealing with constant amount of variables. It does not matter the size that nums get to. We're only ever going to need to keep track of count and max, which is where we get the constant space complexity from. So if you enjoyed this video, make sure to subscribe to the channel. I'm going to continue making more videos from the Arrays 101 series in the Explore card. So tomorrow we'll start doing find numbers with even number of digits, and we'll continue all the way down for all these sections, doing a video for all the different questions. If you want to find existing information on the playlist that I've done before, you can visit my website, rafaelslist.com. This is essentially a guide to my YouTube channel because all the content on my YouTube channel is essentially on this website, just a little more organized. So what I'll do is I'm going to also go ahead and add another section to my playlist here so that way you can find the playlist very easily. So with that being said, really thank you all so much for watching the video today, and I hope to see you all very soon, and happy coding. Later.